All right, this is a video on adding and subtracting rational expressions. Really important thing to remember is way back when we first started dealing with fractions and adding them together, we had to realize that fractions can't be added without a common denominator. What's important here is that we find that common denominator and we do that. And the quickest way to do that is just to multiply the two common denominators together. Now, we could try to find the least common multiple, but in the process that we're heading toward, just multiplying them together is, kind of the most direct way of doing that. So if our new denominator is going to be, let's get this going here. If our new denominator is going to be 3 times 5, which is 15, you ask yourself, okay, what did I have to do to 3 to get to 15? Well, I had to multiply it by 5. Well, if I multiply the denominator by 5, I've got to multiply the numerator by 5, because multiplying by 5 over 5 is the same as multiplying by 1, and that's not changing the value of the fraction. That's really important. I can't change the value of any of the fractions in here and still get what I was supposed to get for the answer. What did I do to the 5 to get the 15? I had to multiply by 3, and whatever I do to the denominator, I do to the numerator to keep it balanced and multiplying by 1. All right, so what's the result? Remember, multiplying fractions is top times the top, bottom times the bottom. So 5 times 2 is 10, 5 times 3 was 15, 4 times 3 was 12, 5 times 3 was 15. Now, when we have a common denominator, we don't add the denominators together. We keep the denominator, and we can make one fraction, and 10 plus 2 would be my new numerator, or 22. So that's what we're going to do with these factors of these rational expressions. So over here, I'll do a couple of examples with you to get you ready to do some of these on your own. Okay, so what I need to do in order to figure out what the two denominators need to be is to get these polynomials into factored form. Because in factored form, I can find out what factors I have and what factors I still need to multiply to get. All right, so let's do that. So I'm going to multiply this first trinomial at the bottom, and not multiply, factor. So I need the factors of 9 that add up to 6. That's going to be x plus 3 and x plus 3. If you need practice factoring trinomials, any of our previous videos dealing with rationals or factoring can help you with those. All right, that's going to keep my x minus 4 on top because all I did was factor. All right, plus 5 over x plus 3, and x plus 3 doesn't have any common factor, so it's where it's at. All right, so now I can take a look at this, and I can say, all right, well, this has two x plus 3's, and this second term only has one x plus 3. So it's going to need a second x plus 3. So that means that I'm going to need to multiply the top and the bottom by that second x plus 3 in order to get the common denominator. All right, so that's going to leave me with nothing different on the left side because it already had everything that I needed. So I'll write it the exact same way. But over here on the right side, I'll need to go ahead and multiply the top and the bottom by x plus 3. Now I'm leaving these in factored form in the denominator in case I'm able to cancel some things out toward the end. You'll see what I mean. All right, now that I have common denominators, I can go ahead and add. But before I add, I do need to distribute here. All right, so that's going to give me the x minus 4, but it's also going to give me plus 5x plus 15, because I'm adding this together, all over one denominator, because it's the same denominator now. And I want to go ahead and combine like terms. X and 5x is 6x. Negative 4 and 15 is a positive 11. All right, all that's over x plus 3 times x plus 3. Now, really quickly, I want to check to see, all right, do I have any more common factors out there? And unfortunately, 6x and 11 don't have any common factors, so this is where I have to stop because nothing else can be canceled. All right, let's try this second example now using the same idea, but we do have a subtraction, so that'll add an interesting dimension right there when we start to combine into one fraction. I need to factor both denominators here so I could find out what I'm lacking as far as factors are concerned and what I need to do to get common denominators. So x squared plus x minus 12, I need the factors of negative 12 that add up to positive 1. That's going to be positive 4 and negative 3. So x plus 4, x minus 3. All right. And then x squared minus 5x plus 6, that's going to be I need the factors of 6 that add up to negative 5. So that's going to be x minus 2, x minus 3. All right. Keep the tops the same because all I did is factor. I didn't change anything. Now I look to see what do I need. Well, both of them have an x minus 3, but I have an x plus 4 on the left and an x minus 2 on the right. So in order to get a denominator that includes every factor that's represented here, x plus 4, x minus 2, and x minus 3, I'm going to need to multiply this by x minus 2 over x minus 2, and I'm going to have to multiply this by x plus 4 over x plus 4. So when I do that, that'll help me get what my new fractions will be. X plus 4, x minus 2, x minus 3 is my denominator. I'm going to keep these separate for now while I go ahead and distribute. 2 times x minus 2 is 2x minus 4. And 6 times x plus 4 is 6x plus 24. All right, now I'm ready to put these into one fraction. X plus 4, x minus 2 times x minus 3. That's my one denominator, and here we go. 2x minus 6x is negative 4x. Negative 4 minus 24 will be negative 28. All right? Now, what I want to do, leaving the denominator in factored form, I want to check to see if I have a greatest common factor or could factor the top any further in hopes that maybe to cancel some things out. They both have a common factor of negative 4. So if I factor out a negative 4, I'll be left with x plus 7. And my denominator of x plus 4 times x minus 2 times x minus 3. Unfortunately, none of those factors match, so this is where we would stop. So that is how we could do our adding and subtracting with rationals.